was having some internet fluctuation. So, we were discussing about this SE, Secure Access Service Edge. So here, it's like it is a framework uh, which helps organization to transform their overall WAN architecture, right? So the main pillar of the main pillars of this particular framework is your network as a service and security as a service, right? So we have multiple flavors available, multiple combinations we can do. We can plan it out. Like you can you know integrate different SD-WAN solution with different SAC solution like Zscaler. So Cisco SD-WAN with Zscaler, Fortinet SD-WAN with Zscaler, right? These are multi OEM SAC solutions where we do the integrations. On the other hand, we have single OEM SASE solutions like Palo Alto Prisma SASE, Fortinet SASE, Ngcloudx SASE, right? Uh, your Zscaler SASE. Now they have their own SD-WAN solution as well. So, now industry is moving towards single OEM SASE solution, KDO SASE. Why they are moving towards the single SASE solution is like manageability, right? Day two operations. Because when you integrate two different solutions together, then dependency on SD-WAN team and SSC team increases, and there are many coordination and other challenges are there, which can be removed with the help of single SASE solution, single OEM SASE solution, right? Because you are going to have one dashboard through which you can control your overall network and security. So here SASE stands for Secure Access Service Edge. It is having two major components, SD-WAN and SSE, Secure Service Edge. And inside SSE, you have Firewall as a Service, CASB, Cloud Access Secure Broker, DLP, right? You have ZTNA, right? And Secure Web Gateway. Okay. And other few components are also there in SSE. So these two components, when you implement the overall WAN architecture as per these pillars, then you become SASE compliant. Okay. Here, your work from home users can connect directly to your infrastructure. Your offices can connect, your branches can connect, right? Your IoT devices can connect, and they can connect securely. And with the help of this architecture, you can upscale your security. I mean, there will be no restriction on your scaling piece. It's not like that any hardware limitation will be there or something like that. You can auto scale your security and you can auto scale your network requirement as per your need, right? These are the benefits of SASE framework, right? Because now you're not getting security through a hardware which is there in your premise. You're getting security through a cloud, right? And in cloud, auto scaling is available. Okay. So if you see this, if you try to understand Palo Alto Prisma SASE in a broader picture, how it is going to look like. So these days, organizations they do have presence in uh, public cloud. They do have on-premise data centers. They have remote users, branches, right? Now, how do I connect all of these things by using internet? Because in legacy infrastructure, we were connecting our locations through MPLS, right? We used to have the primary MPLS circuits, secondary MPLS circuits, and this is how we used to give the connectivity across our enterprise network, right? Branch one is communicating to data center or branch another branch through MPLS, right? If they want to break out to internet, so we were using backhauling. We used to send the traffic towards the data center, and through that it used to backhaul, right, towards the internet. So these things were like it was good when setup was legacy because internet bound transactions were very less. We used to have on premise applications, right? But now what is happening? Everything is moving towards cloud. We are moving our on premise applications towards cloud, which means that there is a migration going on. And we are having more and more cloud applications as compared to on premise applications, right? Now, these cloud vendors, they are available over internet, right? And there is a strong migration of this, you can say, SaaS based applications. If I will give you an example of SAP, Salesforce, Workday, right? Box, all these applications are now becoming SaaS. SaaS means software as a service. So initially, I mean, when we started with these next generation technologies, we used to install these softwares in our premise, right? And we were using MPLS to access these applications, right? But since these applications are now moving towards the cloud and you need subscription, so basically why everything is moving as a service, it's like earlier, piracy was easily done on the softwares because we used to get the softwares and then we used to have the license keys, cracked versions and all that. And we used to use the software in an illegal way. Okay? But with as a service, when you make software as a service, what happens? It's like you have to pay the subscription because you don't have software local copy with you, right? It is available on cloud. Okay? So now, once the service is available over internet, your internet utilization is increasing, your internet demand is increasing. So that's where it is becoming challenging for the organizations to decommission the, uh, you know, I mean, it is becoming challenging for the organizations to take care of the growing need of internet, right? And that's where they have started decommissioning the MPLS links because the traditional way of sending traffic towards the data center and then breaking out to the internet is not going to work. Now we need local breakouts from the branches so that, like this collaboration application, Microsoft Teams, which we are using right now, it is using internet, right? And we all are connected through this Microsoft Teams. And I'm sharing my screen. You're able to see it, and my voice is also going over this internet link, right? So similarly, more and more adoption of these SaaS-based applications is increasing the demand for internet-based WAN connectivities, be it your internet lease lines, your LTE, 5G, whatever it is, right? Broadband. So internet-based leased connectivity are growing, and enterprises, they are planning to give local breakouts to their branches so that they can take care of the growing need of this internet bandwidth. Because take any application these days, Zoom, Teams, Salesforce, SAP, your other CRM applications, your public cloud related applications. Everything is available over internet. These days we don't have on-premise applications, right? We are moving everything to cloud. Our internal applications are also moving to cloud, right? Now, when you are having this diverse architecture, it cannot be catered through MPLS. MPLS will not be sufficient for this, right? So we need a way so that we can use the public mediums available and we can have a secure way to transfer information from one place to another place without getting our data leaked or something like that. And this is where SD-WAN comes into the picture, right? We'll discuss both SD-WAN and this C piece separately. Now just try to imagine earlier, the architecture was like if you want to give local breakout to any branch, right? Let's take an example here. I want to give internet breakout to this branch. So I cannot give unsecured internet access, right? What I will be doing, I will be giving internet access after doing inspection. I need a firewall on branch to do this, right? Similarly, let's imagine there is a customer who is having 500 branches and I want to give local internet access to all the users. So earlier in traditional architecture, I was only having routers, right? And these routers were coming to data center through MPLS network. And from there, I was having the entire security stack through which I was providing the security service. And from there, it was breaking out to the internet. But now what is happening? If I want to give local breakout to all these branches, I would need firewall. And if I would need 500 firewalls on 500 branches, then this will not become feasible solution, right? So here comes the catch. It's like you can have a device here. It could be, it depends on you. If you're a very rich customer, if you can afford 500 firewalls, you buy it, right? If you want to optimize this architecture, then you can have a SD-WAN device on your edge and you can build tunnels with your SSE solution. And this is how your SASE solution is going to look like. Okay. So SD-WAN fabric will take care of your private application traffic flow from branch to data center, and your normal tunnels towards the SEC will take care of your local internet breakout. So your entire traffic will come like this, and then it will break out to internet and SaaS after getting inspection. So here you are getting inspection through cloud. Okay. So you need not to worry about the hardware limitations and all that stuff because it will be taken care by the cloud itself. Right? So whatever transactions you will have, it will go through the SASE. Now this is how it is going to look like in Prisma SASE single vendor OEM. So we have two solutions from Palo Alto. One is like Palo Alto Prisma Access. Now this is the direct replacement, or it is the similar technology to Zscaler Internet Access and Zscaler Private Access, right? And then you have Palo Alto Prisma SD-WAN, right? So this is similar to ZIA and ZPA of Zscaler and similar to Netscope Internet Access and Netscope Private Access. This one service, Prisma Access. It takes care of your internet traffic as well as it takes care of your private traffic, right? Now, this is how it is going to look like. If I especially talk about Prisma Access, so we need to build tunnels from your branch devices towards the Prisma Access, and we will be having one service connection from the data center, right? In mobile devices and endpoints, we will be installing Global Protect. If you have already worked upon Palo Alto devices, you know what is Global Protect. It is a remote access VPN agent, right? So what will happen? Whatever traffic you have, you're generating, if it is going towards internet, then with the help of these IPsec tunnels, it will hit the Prisma access and it will go to the internet. If it is internet or SaaS based traffic. If it is going towards the data center, then it will go to the tunnel and it will go like this and it will access your internal resources. So this is how it is going to be. And if branch to branch communication is needed, B2B telephony and all that, this is how it is going to be, right? We need a subscription for that. I'll let you know. So here, private traffic as well as internet traffic is getting catered through single service, that is your Prisma Access. On the other hand, in Zscaler, you need ZIA for internet and SaaS, and you need ZPA for private traffic flow. In Netscope, you need Netscope internet access, Netscope private access. This is the difference. Okay. SD-WAN is later. We will discuss about it, right? So this is the overall architecture which looks like in Prisma Access. And by default, entire logging will go to the Cortex data lake. So whatever transactions are happening through Prisma Access Cloud, your logs will be generated and they will go to Cortex data lake. Okay. Now this is the traffic flow, right? So with data centers, we build service connections. And from branch, we build, we also call it remote networks, right? And these are IPsec tunnels, which we build from branch towards Prisma Access nodes, right? So I'll discuss about the components as well, what components we have inside Palo Alto Prisma Access. These are the features which you get: app ID, user ID, policies, all that stuff. So whatever you get inside a Palo Alto firewall, same feature set you get inside Prisma Access. Okay. So it is like you're getting the same sort of security posture, whatever you get inside a next generation firewall of Palo Alto. And these nodes are nothing but VM only, Palo Alto VMs, which gets spent inside the cloud. So if I want to access any private resource, my traffic flow will be like this. If I want to access something over internet, my traffic flow will be like this. And on branch, I don't need any firewall. No firewall is needed because I'm getting security through cloud. Okay. SD-WAN router you can place on branch if you are having multiple underlays like MPLS, IPsec, internet, broadband, LT. So if you have multiple underlays, then you can use the SD-WAN router to do the load balancing, the application prioritization. But security you will get it from cloud. Now, what are the components we have inside Palo Alto Prisma Access that we need to understand? So it's like for remote networks, we call it RNSPN, the node which gets provisioned for you. That is RNSPN, remote network security processing node. So this node gets provisioned for you when you onboard any remote network. Now, another best part with Palo Alto is like there are two ways of managing this service. Initially, it started with Panorama, right? We were managing it through Panorama, but later on, it's like, if customer is new, they don't have Panorama, then how they will manage? Then we got the Cloud Manager, Strata Cloud Manager, right? And this Cloud Manager is nothing but a portal similar to Zscaler through which you can do the configuration of your services. So when you onboard any remote network of your network, right, automatically this RNSPN node gets provisioned for you, right? This is done automatically. You need not to worry about anything. You just need to build the IPsec tunnel from branch towards this particular RNSPN node. Similarly, to connect your data centers through Prisma Access Cloud, you need to build this IPsec tunnel and we call it service connection, right? This is service connection and we also call it SCCAN, service connection corporate access node, right? This is unmetered, but these are metered connection, right? Similarly, for mobile users, the node which you get is like MUSPN, mobile user security processing node. So this, if you see the difference between these components, RNSPN is going to provide you security, MUSPN is going to provide you security. This SCCAN is not going to provide you any sort of inspection, right? So traffic flow is like whatever you are generating from branch towards the data center, it will go like this. And your inspection will happen here, not on SCCAN. And if it is going towards internet, then it will break out like this. Okay. And your inspection will happen at RNSPN. Okay. This is
Nathan, can
how
you
it is
repeat
going to
your,
look like.
can you just go back to the previous slide and show how the traffic will be inspected in case of private access from branch to DC?
So it's like when you're sending traffic from branch towards the DC, your inspection will happen only at RNSPN, right? So what do I mean by that? Your traffic is coming from here and it is towards the
Mm-hmm.
data center. So it will hit the RNSPN. Here you have configured your security policies.
Okay.
Is this RSP in Ngcloudx? Sorry to interrupt you.
I'll
So
take the Q&A at last, guys. I'll take the Q&A at
okay,
last.
no problem.
Otherwise, it will be problematic. Yeah. Thanks for understanding. So your inspection will happen like this. Traffic will come from branch. It will hit the RNSPN. Your policies will be applied to it, and then it will go to SCCAN. This internal routing is already done. You need not to worry about it. This backbone routing, it's already done inside the cloud. You need not to do anything for that, right?
Okay.
So automatically, your traffic will be routed towards your data center subnet, and your traffic will reach the data center applications. Right? But on the other hand, if traffic is going towards the internet,
Mm-hmm.
then inspection will be applied through RNSPN and then it will go to the internet, right? So this is your traffic flow. Similarly, for
Okay.
mobile users, if they want to access data center resources, same way it will happen, right? So MUSPN will provide the inspection. So that's why in the name itself, they say remote network security processing node, mobile user security processing node. SCCAN is not having security keyword inside it. It says service connection corporate access node, right? So it
Okay.
means SCCAN is not going to provide you any inspection. Okay.
Okay.
And
Okay.
this SCCAN is unmetered connection. They are not going to charge you anything.
Okay.
This is unmetered. On the other hand, this is metered connection. You need to buy the bandwidth from Palo Alto.
Okay.
Okay. So you need to
Got
buy
it.
the bandwidth, and here you need to buy the number of user licenses. By default, it is 200. Okay.
Okay.
Now coming to the internal connectivity, that how this RNSPN is communicating with SCCAN, or how this MUSPN is communicating with RNSPN and all that. So within the cloud of Prisma Access, these nodes are already connected with the help of BGP peering. You need not to worry about anything. You can onboard as many as you can. Let's take an example. Uh, you have 500 branches, right? So region wise, you will structure your branches, and accordingly you will select your computes, and then you're going to onboard your RNSPN nodes, and then you will be creating your IPsec tunnels with those RNSPN nodes. It's not like that if you have 500 branches, you're going to have 500 RNSPN nodes. No, right? You can share the RNSPN node within your branches as well, right? I mean, if you have, it depends on the architecture. So when we design the architecture, we take this call that how many nodes we need to provision and how to do the segregation of the branches. Similarly, you can connect your data centers through SCCAN. Here you can see we have two data centers, one here, right? And we are connected through these SCCAN nodes, right? And these branch offices are connected through RNSPN. They all are connected. They all are connected through BGP. So backbone routing, you need not to worry about. You just need interconnect license if you want to talk from here to here. For branch to branch communication, license is needed, but from branch to data center communication, license is not needed. You just need to buy the bandwidth. And for mobile user to branch DC connection, you just need to buy the number of user licenses. This is how it is. Okay. So Prisma Access licensing is not totally based on number of users the way we see it inside Zscaler for user license, right? It is not like that in Prisma Access. In Prisma Access, it's like for branch offices. I mean, for offices, you need to buy the bandwidth, and for mobile users, you need to buy the number of licenses as per your user count. Okay, and this routing between MUSPN, SCCAN, RNSPN, it's already there, right? By default, any mobile user can go to the data center. You just need to allow the policy here, and they can also access the internet resources securely. Any branch can go to data center if you have the policy here, and they can also go to internet securely if you have the policy. But if branch to branch communication is needed, then you need a license. Interconnect license is needed. Okay. Now talking about Prisma SD-WAN. When we have Prisma Access solution from Palo Alto, then why do we need Prisma SD-WAN? So what is happening these days? It's like every branch, because we have critical branches, like the starting in the you know starting of this particular boot camp, I had internet outage, right? So I was only having one internet link that went down. My internet access went down, right? So similarly, when you're switching from MPLS to internet based connectivities, now you know you cannot rely on that, right? Because MPLS metrics are really good as compared to internet metrics. You get control jitter, latency, packet loss in MPLS, but you don't get it inside internet lease lines. It depends what type of flavor internet you have purchased from the ISP, right? So we take multiple links, internet lease lines, broadbands, LTs, right? When you have multiple underlays on your branch location, then you need an intelligent device to use all those underlays effectively, and you're trying to build a fabric by using those underlays, right? And do a active load balancing. Okay. Now this is where Prisma SD-WAN comes into the picture, because as we have studied, SASE is nothing but secure access service edge, where SD-WAN is one of its component from network side, right? So you need SD-WAN devices on branches to accommodate this multi ISP WAN connectivities. And then you can build overlays, that is your IPsec tunnels, from these SD-WAN devices towards the cloud service providers like Zscaler, Prisma Access, Netscope, right? So now these tunnels will help you to access your data center resources effectively, right? And securely. We will see these things slowly and gradually, because the only good part with the Prisma Access here is like, you need not to configure multiple things the way we do it with other OEMs like Zscaler and Netscope, right? Here, Prisma Access can take care of your internet access traffic and private access traffic, right? You just need a tunnel from branch. Now that tunnel, you can build with legacy routers as well, IPsec tunnel, or if you have any firewall on branch, you can build your tunnel. But if you have SD-WAN, it's good, right? It's good to have, because you will be able to use multiple underlays, and you can do better packet routing among your underlays, right? So this is what it is. And now everything is getting controlled through a cloud controller, right? So in initial versions, we were having different controller for SD-WAN, different controller for SSE, that is your Prisma Access, right? So now what Palo Alto has done, we have the Cloud Strata Manager, right? Through that SCM, you can control your Prisma access, you can control your SD-WAN, as well as you can control your firewalls. If you're not aware, right now, what Palo Alto is doing, Palo Alto is providing SCM to its customers for management of the products. Earlier, it was Panorama, right? So Panorama was like sort of management server which we used to physically deploy or virtually deploy in our infrastructure. But let's talk about a customer who's new to Palo Alto and they don't want Panorama based any management server. They need cloud based orchestrator or cloud based portal through which they can do the configuration. And this is what SCM is. Oh, CSM is Cloud Strata Manager, right? So now Cloud Strata Manager is available, and through this CSM, you can configure your SD-WAN, you can configure your access, right? You can configure your this firewalls as well. And if I will show you how it is going to look like, so if you will visit LinkedIn, I posted one post. Let me just show you. I think I need to log in. Uh, Posted one post here. Where uh, let me show you what all you can get inside CSM. Just a minute. Yeah, here I'm logged in. So, yeah. So here, if you see this post, here it is. So this is how it looks like. This is the dashboard. Let me just magnify it, right? So this is the CSM, Cloud Strata Manager, right? And you get insights like this, right? So this is your Prisma Access service. Okay. So it's like cloud-based service. You need not to worry about anything, any hosting related thing or something like that. It is already taken care by Palo Alto, right? So earlier it was very challenging because this solution was new, right? And initially people were trying to manage it through Panorama, right? With the help of the cloud plugin. But now Palo Alto has also realized that industry is moving towards cloud-based portals. They are more comfortable in managing their services through cloud-based portal. And that's why now CSM has been introduced, Cloud Strata Manager. Now, why do we need SD-WAN? So I already told you that we can have multiple underlay type. It could be MPLS, it could be internet, it could be LTE, it could be broadband. So there could be multiple, underlays which are available, right? Now to effectively use them, you need a device which is intelligent enough to utilize all of these underlays in active fashion. And this is where your SD-WAN comes into the picture, right? Software defined WAN architecture. Software defined WAN architecture. But this is your overall Prisma SASE architecture. Okay. So this is how it looks like. For my internet and SaaS based applications, I will send my traffic like this through Prisma Access from my branches. And for my data center, rather using SCCAN and all that stuff, I will directly send it towards my data center by using SD-WAN fabric. This fabric is nothing but IPsec tunnel, right? If you don't have SD-WAN, then there is no problem. You can still use Prisma Access and you need SCCAN to connect to your data center. right? So multiple options are there. If you have the SD-WAN technology, then you can use direct fabric to reach out to the data center. If you don't have it, no problem. You can use SCCAN service from Prisma Access to reach out to the data center. Okay. So this is the overview of Palo Alto Prisma SASE, where we have these components, right? Now I will open myself for doubts. If you have any doubt, anything, you can just start asking one by one. I'll stop the recording now. Yeah, guys, please go ahead.
Nitin, I have one question.